Mabuhay! I'm Rafa Jane Lagumbay-Ubanan together with Aiko Balanay, Gabriel Lopez, and Salud. Together, we will be discussing about Titrimetric Method. Let's begin with our objectives. First, explain the fundamental principles of Titrimetric Method. Second, identify and describe the step-by-step procedure in performing a titration. And third, appreciate the practical application of Titrimetric Method in real-world scenarios. Now, what is Titrimetric Method? Titrimetric method, also known as titration, is a technique to measure concentration of a solution using a chemical reaction. It is also a technique used in chemistry to find out the exact amount of a substance in a solution. And it is done by slowly adding a solution with a known concentration called titrant to a solution with an unknown concentration known as analyte until the reaction is complete. An indicator is used to show a color change at the end point, which is often shows that the reaction is finished. Indicator, by the way, is a chemical that shows the end point of the reaction by changing color, while end point, it is the point in the titration where the indicator changes color, suggesting the reaction is complete. Let's dig deeper about titration method. Are you wondering where the word comes from and who developed it? Well, titrimetric method, the term titration comes from the Latin word titilis, which means mark or label. This reflects the purpose of the method, to determine the strength or concentration of a solution, essentially labeling it with a known value. The method was first developed and refined in the late 18th and early 19th centuries. One of the earliest contributors was Francois Antoine Henry Descroizels in 1791, who created a simple acid-base titration technique. Later, Joseph Louis Gay-Lussac, a well-known chemist, made significant improvement to the method, helping to shape the trimetric method we use today. This historical development laid the foundation for modern analytical chemistry and quality control in various industries. Are you curious when to use titrimetric method? The titrimetric method is especially useful in situations where precise and efficient analysis of liquid samples is required. Here are the main conditions where titration is ideal. First, known versus unknown concentration. Titration is used when you have one solution with a known concentration, known titrant, and another with a known concentration called analyte. This setup allows you to determine the unknown value by observing how much titrant is needed to complete the reaction. Second is the visible reaction endpoint. The method works best when the reaction produces a clear and visible endpoint, often shown by a color change with the help of an indicator. This makes it easy to tell when the reaction is finished. Third, quick and accurate liquid analysis. Titration is a fast and reliable way to analyze the composition of liquid solutions, making it widely used in laboratories, especially for quality control and chemical testing. And fourth, simple, complete reactions. It's important that the chemical reaction involved is quick, complete, and has known stoichiometric ratio. It is a predictable relationship between reactants. This ensures that the results are accurate and calculations are straightforward. Students, please take note. Understanding when to apply the titrimetric method is essential for mastering basic chemical analysis.
Now let's talk about the four types of titrimetric methods, starting with the acid-base titrations. These are used to determine the concentration of an acid or base by reacting it with a solution of known concentration or titrant. So this method involves carefully adding the titrant until the reaction is complete, indicated by a color change of an indicator or a change in electrical conductivity. So the examples are hydrochloric acid and sodium hydroxide. So this is a strong acid and strong base titration, where the endpoint is easily determined using the indicator and phenolphthalein. Next, we have the acetic acid and sodium hydroxide. So this is a weak acid and strong base titration where the equivalence point is at a higher pH than the endpoint. And lastly, we have the ammonia and hydrochloric acid. So this is a weak base and strong acid titration where the endpoint is best determined using an indicator like methyl orange. So next type of titration method is the redox titration. So this is a type of titrimetric method that determines analyte concentration by reacting it with a titrant in a redox reaction. Examples are titrating iron sulfate with potassium permanganate. Second is titrating sodium thiosulfate and iodine. In essence, redox titrations are a powerful tool for determining the concentration of oxidizing or reducing agents by carefully controlling and observing the redox reactions that occur between the analyte and the titrant. Next type is the complexometric titration. So this is a type of titrimetric analysis that determines the concentration of metal ions by reacting them with a chelating agent like EDTA. So this reaction forms a stable complex allowing for accurate titration and endpoint using an indicator. So examples include determining water hardness by titrating calcium and magnesium in EDTA, or analyzing metal concentrations in various samples. So the last one is the precipitation titration. So this is again a titrimetric method where a reaction between the analyte and titrant produces an insoluble precipitate, allowing for quantitative analysis. So a common example is the determination of chloride ions, or the CI, by titration with silver nitrate, forming a white precipitate of silver chloride. Another example is the analysis of potash using calcium nitrate as the titrant, which precipitates calcium carbonate and calcium sulfate. So those are the 4 types of titration method. Again, those are the acid-base, redox, complexometric, and precipitation. So it serves a specific purpose in chemical analysis. By understanding their principles, appropriate indicators, and real-life applications, we gain valuable skills in accurately determining the concentration of unknown substances.
For the problem solving, we have a 25.0 ml sample of hydrochloric acid, which is an HCl, is titrated using a sodium hydroxide NaOH with a known concentration of 0.100 moles. So the average volume of NaOH required to reach the endpoint of 27.5 ml. So the question is, what is the concentration of HCl solution? We have the given volume of HCl is equal to 25.0 ml, and the volume of NaOH is 25.5 ml, and concentration of NaOH is 0.100 moles, and the mole ratio is 1:1 from standard acid-base reaction. So for the solution, we have C1V1 is equal to C2V2, where C1 is the unknown concentration of HCl, and the V1 is the 25.0 ml, and the C2 will be the 0.100 moles, and V2 will be 27.5 ml. So our formula, we will be using the C1 is equal to C2 times V2 over V1. So we have the C1 is equal to 0.100 times 27.5 divided by 25.0. So our C1 will be 2.75 over 25.0. So we have here the 0.110 moles. So the concentration of the hydrochloric acid solution is 0.110 moles.
In titrimetric method, it is important to follow the step-by-step procedures so that the titration is well performed. So here are the 5 step-by-step procedures or processes of this method. First is to prepare the equipments. Set up the burette, pipette, conical flask, and other required apparatus, and of course the solutions. Ensure all are clean to avoid contamination. Secondly, add the indicators. Add a few drops of an appropriate indicator to the analyte solution in a conical flask. The indicator helps detect the endpoint of the titration. Thirdly, we must perform the titration. Slowly add the titrant from the burette into the analyte while continuously swirling the flask until a color change indicates the endpoint. Fourth is to record the readings. Note the volume of titrant used from the burette when the color change occurs. This is your titration reading. And lastly, repeat and calculate. Repeat the titration for accuracy, usually 3 consistent readings, and calculate the unknown concentration using the titration formula. Here is the sample video on how to perform the titration in very simple ways. Please watch the video.
You follow these steps. 1. Using the pipette, add a set volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Fill the burette with a known solution. 4. Record the starting volume on the burette. 5. Slowly add the solution from the burette to the unknown solution in the conical flask. You may need to swirl the flask to mix, or use a stir plate. 7. Stop adding when the reaction is complete. The endpoint is reached. This is where an indicator may help because there would be an appropriate color change. 8. Record the final volume. 9. Subtract the final volume from the initial reading. This gives you the volume of the solution added. This volume is called the titra. 10. For an accurate experiment, you should repeat this experiment a few times until you get consistent values for the titra.
So let's proceed to the practical application of titrimetric methods across the diverse fields. So titrimetry, or a volumetric analysis, is a quantitative chemical technique used to determine the concentration of a substance, which is the analyte, by reacting it with a solution of known concentration titrates. So here are some titrimetric methods has widespread across various applications and diverse fields. So first of all is in the pharmaceuticals. So in pharmaceuticals, titrimetric method ensuring drug quality and safety. In the pharmaceutical industry, titrimetry is essential for for quality control. It ensures that the active pharmaceutical ingredients and other components in the drug formulations meet required standards and the dosage specification. So, for example, titrimetric method is developed for determining the concentration of angiotensin 2 receptor antagonists. So, angiotensin 2 receptor antagonists are the medication that treat high blood pressure, heart failure, and also chronic kidney diseases. And also, especially in the patients with diabetes, so they work to block the action of angiotensin 2, the hormone. So it is the hormone that narrows blood vessel and raises blood pressure. So in pharmaceutical preparations, so this method relies on the direct acid-base titrations. It is a mixture of ethanol and water using standardized sodium hydroxide as a titrant. So the titration can be performed visually using a phenolphthalein as an indicator or potentiometrically using a pH electrode. So this method is simple, rapid, and sufficiently precise for quality control purposes, ensuring the potency and the safety of this hypertension and heart failure medication. So the second field is in the food industry. So in the food industry, titrimetric method monitoring food quality and its composition. The food industry uses titrimetry to analyze the various food components. So this includes the
uh, determining the acidity or alkalinity of the or the such as the acid content in the fruit juice. It's also measuring the preservative levels and assessing vitamin concentration such as vitamin C. So, for example, in uh, fruit juice production, titrimetric methods can determine the concentration of citric acid. So, citric acid is a key component impacting the juice taste and also its preservation. This ensures the fruit meets the quality standard for both flavor and the shelf life. So titration can be measured the amount of added ascorbic acid, which is the vitamin C, verifying the nutritional claims on the product label. It's also measuring the total acidity helps assess the potential for microbial growth directly relating to the safety of the product. So a single titrimetric analysis provides insight into multiple aspects of both quality and composition of the what is inside the fruit juice, ensuring its overall suitability for consumption.
Practical application of titration. Titration used to determine the concentration of a substance in a solution, which is crucial in understanding and managing different processes. So, in environmental science, titration is used to assess water quality by measuring the acidity of water samples. So, these help identify the pollutants and understand the health of aquatic ecosystem. For example, titration can measure the concentration of nitrates and phosphates in water bodies. So, in agriculture naman, titration is used to assess soil quality and nutrient content. So, soil titration determines the pH and nutrient levels such as nitrogen, phosphorus, and potassium, which is vital for optimizing fertilizer application and crop yields. So, in education, titration is a fundamental laboratory techniques used to teach quantitative analysis. So, students learn to perform titration to determine the concentration of unknown solutions. So, by this, they develop their analytical skills.
In conclusion, the titrimetric method remains one of the most reliable and widely used techniques in analytical chemistry. This method offers a high degree of accuracy, precision, and consistency, making it invaluable for determining the concentration of unknown solutions. Its effectiveness is especially evident in areas such as medicine, environmental monitoring, food safety, and industrial quality control, where precise measurements can impact health, safety, and regulatory compliance. Through the careful use of standardized titrants and indicators, the titrimetric method provides dependable results that support critical decision making. Whether in the classroom or in the laboratory, mastering this technique equips students and professionals with the skills needed to carry out trustworthy chemical analysis and uphold scientific standards. Students, please put in mind that a strong understanding of titration is essential for success in both academic and real world scientific applications. Thank you. We hope you learn about titrimetric method. That's all for today. Bye and have a great day.